Thanks, everybody. Slides. Cool. Thanks, everybody. So my name's Ian Cooper. I used to share my socials here. I'd put like, I'm iCooper on Twitter, and then we just all went everywhere, didn't we, right? So I'm now on Hackyderm, on Blue Sky. I post tech stuff on LinkedIn now. So I'm wherever if you need to find me. But I just still do try and respond to messages on Twitter if you've got messages after the talk. What are we going to talk about? So I always like to give you a chance to run away by understanding what we're going to talk about. So I want to talk about the patterns that you begin to see in messaging when you move beyond the idea of saying, I've got a producer and a consumer, and I send a message between them. I'm not going to talk about that bit. I'm going to assume you understand at least that kind of idea, that you are sending a message between two parties, right? And it's asynchronous. What we mean by that is that both participants don't have to be present at the same time. So in other words, the idea of a mailbox. I send you something, it sits there waiting until you go and get it. And mailboxes tend to be queues like RabbitMQ, SQS, or streams like Kafka. All right? So we'll assume we all kind of know that much stuff, and then we'll talk about what happens when you get beyond saying, okay, great, I can send a message, now what? Okay. This is me. It just says I'm old. But the most important point I always raise is the one on the bottom, right? I'm just up here because I'm old and I have some experiences to share. You all have experiences to share with other people. I know some of you may think, I know nothing. I couldn't stand up and do something. But there are things that you know that you don't recognize are important because your peers also know them. But there are other people who could benefit from you. And I'd really encourage everyone to try, even internally at work or effectively local meetup groups, try and start a journey of speaking. It really helps you organize your own thoughts, etc. Right? But I'm no smarter than you. If I can get the stuff, you can. All right. So we'll talk a little bit about messaging to begin with. What we'll talk about is kind of the patterns that you start to develop when you go beyond the idea of just as a producer and a consumer, and they're talking to each other. We'll get into an idea after that called an activity, which comes from Pat Helland, which is a useful way to think about what your code is doing in response to receiving messages. We'll get into, there's a topic from the way we talk about human conversation called repair and clarification. So repair and clarification is how we deal with problems in communication. And we'll do it instinctively. We learn it as children, about 3. But repair and clarification is an important topic. And then we'll get a little bit into this idea of conversations, the fact that typically in messaging what we're having is some kind of conversation, and what does that entail? All right. So let's start by talking about messaging. So one way to think about messaging is that you have a requester and a provider. Okay, we'll come back to why we might use those terms a little bit later, but let's define them first. A provider is someone who is exposing some kind of functionality via basically messaging that they want somebody else to be able to use. Okay. And a requester is the person using that functionality. And these are roles, right? So sometimes a given application may be acting as a provider. Other times it may be acting as a requester. In other words, sometimes you might be sending a message. Sometimes you might be receiving a message. Okay. The message, typical thing, has a body and a header. Header is some metadata about the message. Body is the actual content that you want to send. Right. And we send it over what we think of as a channel. And by that we mean we want to abstract away the idea of whatever this underlying protocol is. We want to abstract away the idea of addresses that I'm sending to. What I want is a named thing that I can send messages to. So typically we tend to think about a topic in Kafka or a routing key in RabbitMQ, the name of the thing I want to send something to. So we talk about a virtual pipe because we don't really care how it's implemented. Right? They're unidirectional. Right? It's important to understand unidirectional because we only send messages one way on a given pipe. Right? So if I tried to send them both ways, I'd end up with me sending a request, you sending a response, but of course it just queues behind my request, and that gets very confusing, trying to parse through basically messages to see both. So we tend to be unidirectional. Right? And this notion of requester and provider rather than producer and consumer becomes important when we think about messaging at a higher level. So typically, you may hear the word producer or consumer or sender or receiver, right? The person who is essentially putting the message onto the queue or stream and the person who is reading it off or receiving it. The problem with that is, in different circumstances, you may be the provider of functionality as the producer or as the consumer, right? So if I perform some operation in response to a message that you want to access, right? Like I take a payment for a credit card, etc. Although I may be a consumer, I'm the one providing the API. So alternatively, if you are, say, giving somebody a notification saying, hey, we have had a new store added to our e-commerce site, you may want to know about that. I am the producer of the message, but I am the one providing the API that we think about. So what we want to do is start thinking about the role that we are playing. Are we a provider of an API that somebody else is using, or are we a requester of an API? And remember, you may play both roles at different times, depending upon the conversations that you are involved in. Okay. So, as an example, I've got an app which basically says, I effectively add new stores to our e-commerce site. We'll call it store information, and I'm a provider, right? Because what I want to do is give to search, which essentially builds some optimized for lookup representation of all the stores on our site, information about new stores that have been registered. So I'm the provider, store information, because I am the one effectively surfacing the data, and the search is the requester, the person effectively who is obtaining information from me, right? So that role, effectively, the producer acts as the provider. Okay, we'll show you a different example later on, which has the opposite kind of model. Okay, and the message indicates the new store details. All right. So we can classify these relationships between requester and provider into a number of distinct patterns. So the first one we're going to think about is in-only. And in-only says, I have a requester, and the requester is going to send a message to a provider that is essentially exposing some kind of operation that that requester wants to use. Okay, we'll show an example in a second, right? So my provider has a set of things it can do, and what you do is you just request it does one of those things, and you pass some parameters to it, okay? In this model, we tend to think of it as fire and forget. It's in-only, right? What we mean is there is only a channel going to the provider. There is no channel going back to the requester. So the requester sends the message, but receives no reply. Okay. So typical example could be this. I have an order placement service, which essentially is going to raise an order, and I have a cashier service, which is the requester, which has got a paid-for basket in our e-commerce store, and it wants to hand it over to order placement so order placement can go about kicking off the fulfillment of that order. Okay. So what we have here is effectively a command from effectively place order, which is going across to order placement to say, please place this order. Okay. Typically, what we find with something like in, out, and fire and forget is we have some kind of transfer of control. I don't tend to want a response because I'm essentially saying, at this point, I am done in cashier. My involvement with this whole process is over, so I can't handle anything that goes wrong with order placement. It's nothing to do with me, so I'm going to give you order placement, and you are essentially going to deal with any errors internally to your application. Nothing to do with me, right? I'm a cashier. Why should I deal with order placement problems? Right? So that's why you can use fire and forget in that particular conversation. Okay. The opposite is essentially out only. In out only, the provider is the one raising the message. So the last one, it was the consumer was basically having the message sent to it, and the consumer became the provider. In this model, the producer is the provider because it's going to raise a message when some kind of condition occurs. Okay. So typically what you would see is that the requester tends to be some kind of subscriber who is subscribing to notifications, and those notifications are things the provider's raising when some condition occurs that basically we want to think about. So you can think of out only as being the kind of notification pattern, right? So in only, requester writes to provider, out only, provider writes to requester, and they are basically fire and forget and notification. So classic example, right, building on one we had earlier, I've got something that manages the stores on our e-commerce site. Search wants to know about it because it builds a little optimized representation for people to look up their stores on our e-commerce site. Availability wants to know about it because it does some complex calculations that tell us when a store is available to take orders for delivery and that kind of thing. Pickup locations, where effectively says, okay, I want to know about basically store information because I have to collate it with some data about restrictions on vehicles that can come to the store and pick up goods, etc. And this is typically what we think about, notification, as publish subscribe, right? So pub sub is really just a form of this out-only pattern, right? Which says, I have a provider, the provider raises a message, it doesn't listen for any kind of receipt or information from its subscribers. In fact, it doesn't know about the subscribers, right? That means it's very loosely coupled, because if it doesn't know about its subscribers, there's a significant loose coupling. There is more coupling in request response, which we'll see in a bit, and we'll talk about what that coupling is. Okay. So this is in-out. Commonly, you might think of this as request response, right? So I have a requester, it sends a request to a provider, so it is, in a sense, triggering an operation that the provider exposes, and a response comes back to the requester. Notice that there are two channels, right? Because channels are unidirectional, there is a request channel, and there is a response channel. Now, either you basically pre-agree two different channels, or essentially the request in its headers has a reply to indicator which says, please reply to this channel. Why might you do that? Because sometimes the reply to channels are ephemeral and they may contain information to effectively route a given response type from a request, right? Otherwise, you may just say, okay, all replies go back here. Okay. So, yeah. So the message triggers basically a response. Okay, so first we get a response. So typical thing that might happen here, I've got some basket app or service in my e-commerce site, and I have some cashier service that takes payments for it, and I say, I would like to run the checkout operation, Mr. Cashier, so that effectively I can pay for the contents of my basket, and the cashier would respond saying, oh, there's a successful payment for me, right? So the operation I'm exposing effectively takes the payment, and I want to say, take a payment for me. And I want to know that this payment operation has happened successfully, so I can say, this is a paid-for basket, okay? Right, so typically what I'm sending, we tend to think of as a command, right? It's an instruction for you to do something. Please do this. Commands we quite often think about as expressing the future. The future world needs to look like this. It needs to look like a world in which this basket has been paid for, and let me know when you've done that. All right? So the response basically comes back to us, okay? All right. So this is basically request response or command acknowledgement, right? Where we trigger basically an operation on a provider, and we get basically a response back. All right? Okay. So this example is also in-out, but we think of this one as query and result. So effectively, I basically have all the items you put in your basket, and as you add items to your basket, I want to show you what the delivery cost is. At a certain point, you put enough value of items in your basket, we'll offer you free delivery, for example. Okay. So here, what we're saying from the basket is, can you give me the delivery fee, and they get the delivery fee back. So we can think about this as a query. I'm giving you a query. It's not a command. I'm not instructing the world to look like something. I'm asking, what does the world look like in this case, right? So there's I'm not making a statement about the future. I want to understand what the past more. What does the fee look like for this value? Okay. So here's the operation, which says basically I'll tell you the delivery fee for this given item. And I return a result indicating the fee for the current state of the world. So in-out, as well as basically being a pattern you can think of as request response or command acknowledgement, is also a pattern that supports query and result. Notice again, 2 channels. One channel which basically we say, okay, give me this question, and another one that says, give me the result back to the question I'm going to ask you. We'll come back a little bit later and we'll talk about issues of state management and being non-blocking in basically the basket. So just park that thought if you've had it in your head, and we'll come back and do that later. There is slightly more coupling here, right? So on out only or publish subscribe, I don't really have to know much about my subscribers. The broker can really handle that. I just basically say, I'm just sending messages. What do I care? In and out, there's more coupling. I kind of need to be aware, typically with an in message, effectively, who is the request that's providing that. So as soon as I get in, there's some coupling. And the out, essentially in this case, it tends to go back to the person that sent me the message. So there's, again, slightly more coupling, right? Slightly more things to worry about if we want to do change. Okay. So out in is another option, right? So the provider sends a message out. We always say out and in terms of the provider. So it's in if the provider receives the message. It's out if the provider produces the message. So this is out in. Sometimes we think of this as solicit response. So essentially, I've got some set of subscribers, and I want them to tell me something. Right. So typically, with the out-only pattern with subscribers, what I'm saying is, I'm just telling you stuff. I don't really care if you get it or not, right? But with this model, I want you to tell me something, typically used to renew leases and that kind of thing, right? So the subscriber confirms receipt of provider solicitation. So a classic model could be you have some couriers, and the couriers basically want to do jobs. So the delivery service basically has jobs that drivers can fulfill, and the couriers basically is a service that represents basically jobs that we're assigning to given couriers. And what may happen is we may say, well, what I want to do is send a message to say to you, are you ready to receive jobs? Question?
What's the difference to request response except the direction you painted it?
So the question is, what's the difference to request response apart from the difference you painted it? There isn't one, right? We'll come back to that. Hold that thought, right? We'll come back to that. So we'll explain more about that at the end. But yes, so it's just a difference of direction. It is that the provider is in charge of the operation. Okay. All right. Let's talk about activities for a minute. So what are activities? So activities, essentially, are a general idea of code and state that you'll need inside a given application during messaging. So when I'm running something like in only or fire and forget, right, then I just send you a request to my provider, right? Because I don't await any kind of response from you, I don't need to manage any state about that operation, right? I fire it, I move on with the rest of my code. I'm done with it as far as I'm concerned. Similarly, if what I want to do is a kind of out-only operation, then the provider just needs to basically put a message out there, and generally a broker will deliver it to all my subscribers. Again, I don't really need to think about my subscribers at all, right? So I don't have to tend to maintain any state. With request response, though, there is a different bit of a problem. Because when I make a request, I'm now awaiting a response. And I have to correlate that response. And what I don't want to do is essentially block a thread waiting on that response. Right? Because that just chews up my resources. What I want to do is effectively save some state in the requester that says, I have dispatched this given request. At some point, there will be a reply. And then basically listen on the reply thread on the reply queue with a separate thread that says, hey, when a reply comes in, I will go and pick up the state for that job that was basically suspended and run the rest of the process. So the model tends to look a bit like this, right? I have a requester. It basically pushes a request. It waits for a response. It gets a response. It completes basically the activity that it's working on, right? And that's the way we avoid becoming blocking while we wait for responses. Otherwise, and technically you can, if you like, send a message and then just block polling for the response to come back on the other channel. But at that point, you gain no real advantages over a synchronous conversation. So that's something like HTTP or gRPC, where effectively we block waiting for the result. Now, you may say, hang on a minute, Ian, I can do async await or like on HTTP or gRPC. You can, but your service can't crash because you are in the middle of an operation. With this model, because we save the state to disk, the service could crash. We'll just wake up again, and then we'll pick up anything off the queue, and we'll process the results that came back in. So we are resilient to failure because we are asynchronous, right? I talk slightly more about that on tomorrow's talk about reactive architectures. Okay. So the request effectively, the requestor must be stateful. Okay. Provider, under this model, we've got no indication that there's a requirement for it to be stateful. It could be stateless, right? Okay. So, there is an option for the request to remain stateless, and that is essentially it says, in my request, I contain all the information about the request and the current state of the workflow that I'm running in the requester. Consumer simply updates that, passes the whole thing back to me. Okay. And when I pick it up, I just say, okay, what is the current state of this thing I've received on the reply channel, and I'll run with the rest of it. Now, essentially, in synchronous conversations, that's basically what HATOAS does in HTTP when you think about REST. Same principle can apply if you desperately don't want to be stateful in your requester, is to include all the information about the job in the message. When you get the reply back, you just read the contents of the message to determine what I should do next. Right? Okay. So an activity is a term coined by Pat Helland for essentially this code that runs in response to a message and state that you may need to store in order to basically proceed with the steps of whatever this activity is that's response to code. So initially, some kind of message comes in, some kind of trigger, right? Could be a timer click, could be a message from another application, and that kicks off work I need to do. So here, the cashier effectively says, well, I want to basically figure out what the price is, so I want to price the basket, check I've got the up-to-date prices, check they're the right version, right? I've priced the basket, and then I basically want to talk to the payment provider to get payment for effectively the contents of the basket. So I've got two steps. And in my activity, at some points, I need to wait. I need to wait when I ask for the price and get the response back. And having got the response back, I need to effectively wait when I ask the payment provider for to pay with the customer's credit card, and I get the response back saying it's paid for. And effectively, now I've turned this basket into something that could be an order, right? And that is an activity, right? So it runs in response to receiving a message, stores any state associated with the activity, and it knows the message is it's sent and received so it can be reconstructed, right? So in theory, if you crash and wake up again, you know what state you are in, and you can figure out what you sent and received, and therefore where you are. Okay. So to some extent, you are used to seeing code like this. You just don't call it that, right? If you play with AWS Lambda or Azure Functions, and you receive basically event off their framework, and you write some code in response to that, that is effectively your activity. That's your activity code that you're writing there. Okay. If you use Brighter, which is the one I work on, right, then you will probably find the same thing. You'd write a handler in Brighter. We'd receive a message from Kafka or RabbitMQ or like. You'd run your classic C# code, and at the end of the handler, you return, and that would be the activity done, right? Typically, at Brighter, you might have multiple activities here, or multiple bits of code here forming the activity. So you'd have a handler for this and a handler for this, and you'd have a you send this and send this. So you might actually have 2 sets of handler code before you complete the whole activity, right? Activity typically needs a correlation ID. So the correlation ID tells you we're dealing with the same thing. It may be a natural ID, so here, basket ID may be good enough to correlate, or you may have to generate some kind of GUID so you know, what is this, when I send and receive stuff, what is the activity I'm effectively referring to, right? Otherwise, it gets a bit easy to get lost. But typically, there are often natural correlation IDs for you. Okay. Also note, this is an activity. We're not necessarily storing any state over here in the payment provider. We just call external payment provider effectively and get them to actually take the credit card and all the details, etc. But it could be stateless, right? And that is still technically an activity. It's code run in response to basically to triggering by an event. Okay. But there may be other activity state, right? So you may have state in some kind of provider where effectively, for example, we want to solicit a response from a provider because we say on an out-in pan, I want to know that I should be sending you messages. I want you to tell me you're renewing the lease. Typically, you may also maintain state there about the communication that you're undergoing. Right. Okay. Repair and clarification. Okay, like I said, repair and clarification, a term comes from what we learn to do when we clarify conversations, right? When people don't understand what is going on. Okay. So, when we think about repair and clarification, right, there are lots of failure scenarios in messaging that we probably ought to worry about, right? Out of order messages, incorrect messages, loss of the broker, lots of ways distributed systems can fail, right? We may worry about consistency, right? How can I assure myself that what the requester thinks is happening is also what the provider thinks is happening? How can I ensure the state in those 2 activities is actually the same, right? And we also may be concerned about latency, right? In order to get availability via messaging, we basically agree to latency, queues. So queues give us availability because if the application crashes, the work is held on the queue, but it creates latency, right? Because things will queue. Okay. So, when we think about failure, we may want to think about, what happens basically if we can't take the payment? What does Basket care about knowing, right? What happens if I fail to send the checkout message? Okay. What happens if the checkout message is ill-formed, right? I've changed checkout message on this Basket team and I forgot to tell the cashier team that that's happening. Okay. And how do we cope with latency? So there are some patterns we can think about in terms of repair and clarification. Let's skip this slide. I think it tells us anything. Okay, cool. Right. So the first one is no fault. So in no fault, what we're saying is provider makes no attempt to communicate anything about failure to basically the requester. Requester says, please do some work, or some form of fire and forget operation, and I simply say, yeah, tough. I'm not going to tell you what went wrong. Typically, the requester has no opinion about faults in this case, right? There's nothing the requester can do if the provider faults. Typically on a kind of fire and forget operation, it may be that I don't care what happens. Like earlier on we were saying, the Basket doesn't care if order placed has a failure. There's nothing Basket can do about it. And there's nothing about the order placed position and relationship. It's handed on the work. There's no point in it being signaled work. Typically, the provider is essentially going to have to manage those internal faults itself, either by basically, retrying or application logs or traces effectively alerting operators that something has gone wrong. So, for example, here I've got one that basically is an out-only operation where effectively the provider, which is store information, raises information about a change store to search. And essentially, I make no attempt in search to tell the provider that I couldn't take that particular restaurant and build my search representation. There's nothing store information can do about my failure. There's nothing about how I build search information, etc. All right? So message triggers fault. So this tends to lead to robust in-only. It would also do robust out-only as well. Right? Where you don't have a reply channel, you can do something called message triggers fault. A message triggers fault says that even though there is no reply channel, okay, I'm actually going to give you a message in the event that there is a fault. So in other words, you can think about this as being there's a fault-only channel, all right? And so essentially it says, okay, in the event of faults, it's possible the requester can do something, so I'll send a message back to them and they can take some operation. Okay. So similarly, message triggers fault can be used in this way, etc. I've got a cashier and order placement. I place the order. We've said effectively that is essentially a fire and forget operation because there's nothing I can do about it. But perhaps I decide that it's important to the cashier to know that basically there's been a failure. So, for example, they can cancel the customer's order. So maybe I have a fault channel to go back, right? That's message triggers fault. We can also have fault replaces message. And that says we do have some kind of response channel, and any message after the first can be replaced by a fault, right? So we can say, actually, what I can give you on the response channel is going to be an error message, which tells you that something has gone wrong. So the difference here is just whether or not, essentially, you have an exceptional condition where, effectively, you can replace faults, but you don't normally send any kind of response, or you do normally send a response, and you can replace the normal response with an error. Okay. So pricer and payment provider, in the event that basically I can't take a payment, typically I would want to understand that I couldn't take the payment, and so I would reply back on the normal reply channel, which normally says, hey, this basket's been paid for, with a fault saying, I couldn't take payment and a reason why, right? Invalid card, insufficient funds, or maybe a technical issue. I couldn't talk to the payment provider, and the price may be able to react to that situation. Retries. So another way of handling faults is simply to retry the operation. So we may decide that after a certain amount of time, if we don't receive a response where we are effectively in an in-out model, we will retry the operation. Okay. So the producer retries response within the time window. Okay. All right, I'm running a little bit low on time, so I will move a little bit faster through some of these. My apologies for overrunning slightly. It's the first time I've given this, and I misjudged the timing. All right. Transactional messages or outboxes are another pattern. So essentially my problem may be that I need to make sure that when I have my local state updated in the pricer, the corresponding message has been sent basically to the downstream for me. And the problem can be if I'm writing to a database and writing to a message queue, how do I guarantee that happens? And typically that's where we use the outbox pattern. So we write the messages you want to send to the database along with the change of state, and then we poll basically that table for sent messages and send those instead. And that basically allows us to keep in correlation. The risk, of course, though, is we send duplicates. And because we have to risk basically sending duplicates, what we do is we keep a notification of the messages we've received, technically in an inbox, and then we can basically say, have we seen this message before? We've been sent a duplicate because our reply got lost and effectively somebody sent effectively a message again from their outbox, right? In order to send again, I have to have an outbox in order to make sure that I can cope with the fact that it may be that you send me duplicates because it may just take me a while to work on something or my reply might have got lost. I need an inbox to remove those messages. All right. Conversations. So conversation is a series of paired actions between participants, two or more participants. You can either play the role of a requester or a provider, and you may swap around the roles that you're providing. And you tend to take turns. So in human conversation, this important idea is called turn-taking. In other words, we don't both speak simultaneously. I speak, and then you listen, and then you reply, etc. And we both take turns being the speaker, right, and the listener. So in the same way, we take turns being a requester or a provider, and each interaction tends to relate to a prior interaction. So we know it's a conversation because we're talking about something, the same thing, and we're replying or responding on that given topic of the conversation, right? Typically, we need a correlation identifier between pairs of interactions or a conversation identifier for the whole thing, and generally we can often be a natural ID. So in human communication, we do this turn-taking. In software, we need to basically think about doing something similar, right? We take in basically a message. You wait while you're waiting for a response, and then I give a reply, and you can go back and listen to the reply. And this dialogue style creates an element of choreography between all the participants in our conversation. Okay. Let me just get to the picture. It'll be easier. Let's not worry about that one. Let's skip that picture for time. All right. So what happens is I get a series of interactions that form the conversation between two apps. Each party is effectively part of the conversation. Each party is potentially running an activity code for internal state. Each one knows essentially probably quite a lot about the whole conversation because they're recording messages received and messages sent. And the conversation state is effectively the state of those individual items of conversation that lie between them. Okay. We do orchestration within the component for the given activity that we are looking at. Right? We don't tend to do orchestration by some external process manager that runs some kind of saga, because typically orchestration can happen as part of the state of a given app. So avoid, like the plague, that's what killed SOA via ESBs, external process managers. Okay. So overall, if you imagine a model where I had a cart and I had some seating, I was buying tickets and I wanted to take payment, right? And I had a model where I said, reserve my seating, check the payment, confirm the purchase, then basically go back and confirm that I've got the payment, so those seats should be allocated to me. I have a series of interactions which form a conversation about buying seats. I have orchestration between the cart and the payment provider, and I have orchestration between the cart and the seating allocator. And overall, those two bits of orchestration form part of my overall choreography. So when you see these terms, orchestration and choreography, quite often what you're led down to believe is, oh, hey, choreography just means I'm sending notifications everywhere, and orchestration means I'm running a saga pan. And it doesn't. It shouldn't really mean that, right? At times, you are acting as an orchestrator. You're running a workflow. You're running an activity, basically. You're running a workflow that essentially controls messages being sent to other items. And that's for causality purposes. A needs to happen before B needs to happen before C. I need to reserve the seats before I take the payment. Once I have the payment, I can allocate the seats. I need causality. I can't use events. You'd use orchestration, but you can use it within the individual activities. Choreography is the whole dance of these three components because I have two separate orchestrations rather than one overall orchestration. Right? There's an orchestration between cart and payment and an orchestration between cart and seating. All right, we're at the end. Sorry for overrunning. Quick summary. So someone asked a question earlier and said, hey, what is the difference between kind of out-in and in-out, etc. Right? The thing is, all of messaging is just, I have a producer and I have a consumer and I have some middleware in between. The problem is that's not enough for you to start reasoning about how you are using messaging in a system. Okay. To reason about using messaging in a system, you're going to have to think about the roles that the producer and consumer are playing, i.e. a requester and provider, who has control, who owns the current state, in other words, your activities and your orchestrations, how we maintain consistency, things like outboxes and inboxes, what do we do in the event of failure, so no fault, message replaces fault, fault replaces message, how we create transactions, which basically is this idea of activities again, and what coupling we create, right? If you are out only, then essentially your coupling is very low, right? Because you don't care about the subscribers. If you're in only, the coupling is more because you care about an operation, but not quite as much as in-out, where you've got quite a lot of coupling, all right? So all of these things are concepts you have to start worrying about on top of producer and consumer. All right, obviously I don't have time for Q&A. Apologies for overrunning. It's the first time I've done the whole thing, so I was a little bit out of my timings. But thanks very much for listening.
We have 4 minutes before lunch if anybody has questions. Okay, hello.
What tools in your company do you use to implement that conversation? Some libraries, some workflow managers? Something?
Yeah, so something like Writer will do most of that, right? Because essentially any code that runs a handler in response to a message typically can act basically to form an activity. What you just need to agree is things like conversation IDs and correlation IDs in your headers so that you can trace stuff back. Also, what's really useful nowadays is telemetry. So basically implementing something like open telemetry so you can see traces which help you understand these flows, because traditionally we've quite often been blind to seeing these things, but tracing helps us now be able to see these conversations that are ongoing. Great question.
We have another one here.
So, who owns the conversation? Who stores information about where we are in the conversation?
Yeah, it's a good question. So if you remember that diagram where we had basically 3 nodes, right? It turned out that the cart in the middle owned two basically dialogues, right? The overall conversation consisted of 2 separate dialogues. In the end, cart ends up owning most of that conversation, but you don't necessarily always have to have a single owner, which is what choreography implies. Choreography implies actually multiple participants might own the overall conversation, but specific dialogues tend to be owned by one orchestrator. That makes sense?